I'm going to show how to solve a system with 3 equations and 3 unknowns and some parameters or constants to the right. This system is gonna be consistent and independent. Consistent in the way that it has a solution that we are gonna find. And independent because it's gonna have just one x, one y, and one z as solution. Just one solution consisted of one value for x, one for y, and one for z. Start writing the equations, the original equation, call this the equation 1, equation 2, equation 3. And you notice that if you subtract this row minus that row, subtract the first row to the second, you get a 0. You can say x minus x gives 0. But you can say 1 minus 1 is 0x. 2 minus 1 is 1y. 2y minus y is 1y. Or 2 minus 1 is 1y. And c minus c is 2c. You are subtracting, but this is a negative number, and then it adds at the very end. And 5 minus 0 is 5. And then you get a 0 here. And then try to find a 0 here, but you know that subtracting again, you get the same answer. This is the third equation minus the first equation, and gives 0, 0, and 2c, and 4 minus 0, 4. Notice we were trying to find a 0 here and a 0 here, and we are lucky because the same operation that got the 0 here with the first row, subtracting the first row, gives a 0 here, and it speeds up the process because we got the row echelon form. That is a way to solve the problem this way. From this, you get theta equal 2, you know? Then put the 2 here, substitute the 2 here, and you get a 4, move it this way, minus 4, and get a 1. Then you get y equal 1 immediately. Now, with y equal 1 and c equal 2, you got x plus 1y minus c 2 equals 0. Now, x equal to, this is minus 1 here, and pass over there to plus 1. And then you had only one answer. X is 1, y is 1, and c is 2. Theta is 2. Then this is one answer. Just exactly. The system is independent and consistent because it has solution. But independent, just one solution. Just one solution. We can improve this method going further with this equation here that says s plus y minus c equal 0, y plus 2c equal 5, 2c equal 4. Instead of finding c here, go further and say, I'm going to use this as a pivot. And then, this is now equation 1, the new equation 1, the new equation 2, and the new equation 3. And then you say, I'm going to get a 0 here, this way. Oh, first divide this. I mean, E1 is the same. You can make variation of the method. E2 is still y plus 2c equal 5, and then 1/2 of equation 3, just to get a 1 here, c equal 2. Divide by 2 each side, 1/2. And then now, you know that it's going to be easy to get a 0 here. Then 1/2 of equation 3 converts this equation in c equal 2. And now it's extremely easy, gets 0 here and 0 there, using the equation 3, the new equation 3, c equal 2. How? Just the first plus the third give us x plus y, and adding those at this level, this and that, with c equal, we are adding equation 1 plus 3 is a 2. From this, get a 0 here with this operation. Equation 2 minus 2 equation 3, and you get this 0 at this column. And then you get y, no c here also, c is there. And then equation 2 minus 2 equation 3 gives you 5 minus 4 and gives you 1. Then at this level you have this, and c is still the third one, is c equal 2. And we are much more better because this c is only in the third equation and zeros here at this level. Do the same with the y, Just, this is gonna be, to get a 0 here, will be the first minus second, and you get 0 there. First x minus second, in this case, in the column of the y's, is 0. There is no 0 here, and you get x equal equation 1 minus equation 2 gives here a 1. I have a 1 here for y already, and a 2 here for c, and this is an echelon matrix, but in each corner we have only one coefficient different from 0. For the entry is 1, and this is a 1, and this is a 1 for C also. Then we are using the classical Gauss-Jordan method that finish with a matrix like 1, 0, 0, and here numbers 0, 1, 0, here numbers, and 0, 0, 1, here numbers, and of course you have here in front of you the solution: x equal 1, y equal 1, c equal 2. The unique solution, that's what I said, that it was an independent system. Solution unique, only one solution. you can try to check. Replace those numbers in the initial equations. 1, 1, 2. Over here, 1 plus 1 minus 2 is 0. 1 plus 2, 3 plus 2, 5. 1, 1, 2. 1 plus 1 plus 2, 4. This is the solution. And just a unique solution. The solution has 3 results, x and y and z. But as a vector, it's just one vector. Or a point. But one solution.